A vehicle of mass 6,000 kilograms is moving up a slope inclined at an angle of alpha to the horizontal, where sine alpha is 6/49. The vehicle's engine exerts a constant power of P. The constant resistance to the motion of the vehicle is R newtons. At the instant the vehicle is moving with velocity 16/5 meters a second, its acceleration is 2 meters a second squared. The maximum velocity of the vehicle is 16 meters per second, and we are asked to determine the value of P and the value of R. So initially, starting with a sketch of the situation, just to help us understand what is actually happening here. So we have a slope. I have a vehicle on this slope. We are going to have both resistances to motion. So we're going to have a driving force, let's call that D. We're going to have a resistance, which we've been told to call R. I'll call that the normal reaction in that case. And we are told that the mass of this car is 6,000 kilograms. We have an angle of alpha, which means this angle here must be alpha. And we are told that if we have this triangle, and I think in this question we probably won't need necessarily the full triangle, but it's always good practice. We're told that if we have the angle alpha, sine alpha, so opposite over adjacent is 6 for the opposite, and adjacent is 49. The maximum velocity of the vehicle is 16/3 meters a second. Maximum velocity implies to us that the acceleration is equal to 0 at this point in time. It's an important part to take out of the question. We're going to be using power equals force times velocity, or in this case it's going to be the driving force. Sorry, it's not going to be driving force, it's going to be force times velocity. Okay, so let's resolve up the slope. Resolving up the slope parallel to it, we have my driving force. We're going to be using Newton's second law, F equals ma. So balancing all the forces on the left hand side, have the driving force minus the resistance minus 6,000 g sine alpha is equal to mass, which is 6,000, times the acceleration, which is a. And actually, if you put in, if we start to simplify this a little bit, we get d minus r minus 7,200. So this is the result of multiplying 6,000 times g, which is 9.8, and times sine theta, which is 6/49. This will be equal to 6,000 A. Now, using the information in the question, when A equals 0, V equals 16/3 will lead us to an equation, because now if I take my equation here, I get D minus R minus 7,200 will be equal to 0. So if I add R to both sides and I add 7,200 to both sides, I get that the driving force, or the D, equals 7,200 plus R. And actually now what I can do is I can substitute this into my equation for power. So P equals velocity, I'll put the velocity first because it makes more sense, 16/3, 7,200 plus R. And if I multiply both sides of the equation by 3 and expand the bracket, what we get is that 3P is equal to 115,200 plus 16 times R, which is 16R. Okay, now I can take exactly the same approach with the other information I'm given. I can't solve this, I can't find my power, I can't find my resistance because I need more information in this situation. As I've got two variables here, you'd suspect that I'm going to have to set up simultaneous equations to solve this. So I'm now going to use the other information, which is the velocity of 16/5 and acceleration of 2, in order to set up another simultaneous equation. So we had velocity was equal to 16/5 and acceleration equal to 2. So substituting that into my equation, I get d minus r minus 7,200 is equal to 2 times 6,000, sorry, which is 12,000. Again, I want to add r to both sides, and I'm going to add 7,200 to both sides. Sorry, just that is 7,200 to both sides. So I get d is equal to 19,200 plus r. Now when I substitute this into the power equation, power equals force times velocity, so I'm going to put the velocity first of all just because it can act as a coefficient, 16/5, times the force, which is 19,200 plus r. Times both equations by 5, and I get 5p is equal to 16 times 19,200 gives me 307,200 plus 16r. Now if I call that equation 1, the equation that we got previously was 115,200 plus 16r, so I've got 3p equal to 115,200 plus 16r. If I call this equation 2, I know chronologically they're not. What I'm going to just say then is equation 1 minus equation 2 will give me 2p is equal to 192,000. And so I can divide this by 2 to get that p equals 96,000. Now all I'm going to do is sub that into one of the equations. Let's sub it into equation 2 because it seems to be dealing with smaller numbers. So I get 3 lots of 9,600 equal to, sorry, it's 96,000, not 9,600, is equal to 115,200 plus 16r. So I'm going to subtract the 115,200 from both sides. The result of this gives me that 16r will be equal to 172,800, and when I divide this by 16, finally, to get an answer, we get that r is equal to 10,800 newtons. So power is 96,000 watts, or we could say this is 96 kilowatts, and r is 10,800 newtons, or we could say this is 10.8 kilonewtons, but it doesn't specify what unit we have to use. Okay, well let's have a look at how the marks are awarded in this question. Okay, now first of all, if we've done the resolving and we've shown the resolving horizontally correctly with the forces, we get M1. If we use at some point the power as I've done down here, then I can get a standalone mark just for using power. Additionally, with this equation, we get an accuracy mark if the values are substituted in correctly and used correctly. Then, if we get the correct equation substituting in a equals 0 when we've got the v equals 16 over 3, I get another accuracy mark. Okay, so there are our first 4 marks. Going on to the second slide, again what we're going to get here at the top is we get a method mark and an accuracy mark if we've in fact used the resolving correctly. And then finally, if I get to the correct equation in P and R, I get an accuracy mark. Working through at this point, if I show some sort of working for simultaneous equations, I get a method mark, and then finally, if I get both the power and the resistance correct, I get a final accuracy mark. I hope all of that made sense and that you understood the question.